So I'm going to do a proof by induction for 2 to the n is less than or equal to n factorial plus 2 for an n that's a natural number such that it's greater than or equal to 3. So for the proof, we always want to start with the base case, which in this instance is 3. So we check p of 3. So p of 3, we have 2 cubed, which is equal to 8, which is equal to 3 factorial plus 2. So we know p of 3 is true. And now that we've established that the base case is true, we go on to assume that p of k is true. Okay? And from there, we want to show p of k plus 1 is true. So we know p of k in this sense would be 2 to the k less than or equal to k factorial plus 2. And for this, it would be 2 to the k plus 1 is less than or equal to k plus 1 factorial plus 2. So I'm going to start with the left side. So we have 2 to the k plus 1, which is equal to 2 times 2 to the k, which we already know 2 to the k is less than or equal to k factorial plus 2. So we can say this is less than or equal to 2 times k factorial plus 2. Okay, so I know I'm going to want a 2 at the end, so I'm going to factor that out. And I'm going to say 2 times k factorial plus 1 plus 2. So that's equals to that. And then I notice that if we leave this, we have k factorial plus k factorial plus 2 plus 2. So now I want to show that this is less than or equal to this. Now I can say that k times k factorial plus k factorial plus 2 is greater, because we have a k factorial here, we have a k factorial here, and k times k factorial is always going to be much bigger than this added 2 because we're starting with 3. Okay, so then if we do a little bit of factoring, we can say that this is k factorial times k plus 1 plus 2, which we know is equal to k plus 1 factorial plus 2. Therefore, we have shown that 2 to the k plus 1 is less than or equal to k plus 1 factorial plus 2. Thus, this proves that for all n that are natural numbers, when n is greater than or equal to 3, 2 to the n is less than or equal to n factorial plus 2. And that's a proof by induction.